Everyone, myself M.R.RAJAKUMAR, Assistant Professor, Department of Mechanical Engineering, Rohini College of Engineering and Technology. In this video lecture, we are going to discuss about the second law of thermodynamics. Course outcome: students can, after study this subject, students can able to explain the concept of second law, entropy in the thermal system, and apply entropy for second law applications. Highest coefficient level K3. Second law of entropy, it includes the heat engine, refrigerator, heat pump, statement of second law of equivalence, correlacy, Carnot cycles, reverse Carnot cycles. We will discuss about one by one. The limitation of first law. The first law of thermodynamics states that a certain energy flow takes place when a system undergoes a process or change of state is possible or not. According to the first law of cyclic process, work is completely converted into heat or heat is completely converted into work. Heat and work are mutually converted into each other. But from experience, this is not true. The second law of thermodynamics. The second law of thermodynamics gives more information about thermodynamic process. Second law may be defined as heat can not flow itself from cold body to a hot body. The second law is also used to determine the theoretical limits for the performance of mostly used engineering system like heat engine and heat pump. The Kelvin-Planck statement of the second law of thermodynamics states that it is impossible to for any device as heat engine that operate on a cycle to receive heat from a single reservoir and produce net amount of work. This statement may that only part of total heat absorbed by heat engine from a high temperature is converted into work. The remaining heat must be rejected at a low temperature. You can see this image, the heat engine, the heat sources. Here we are giving the input of heat source input, that is heat supply. We get the work output. The heat engine that is converting 100% of heat into 100% of work. This system is not satisfied second law. So the statement can be also expressed as no heat engine has 100% of thermal efficiency. Classiest statement. Then classiest statement of second law of thermodynamics is here below. It is impossible to construct a device at heat pump and operate in a cycle and produce no effect other than the transfer of heat from lower temperature to higher temperature body. This statement means that heat cannot flow from cold body to hot body without any work input. Then comparison, here we can comparison the Kelvin-Planck statement and Clausius statement. Kelvin-Planck statement means it is applied to heat engine. The Clausius statement, it is applied to heat pump and refrigerator. In Kelvin-Planck statement, it is negative statement. It is Clausius, it is also negative statement. And Kelvin statement, it is based on experimental observation and no mathematical proof. It is based on experimental observation and no mathematical proof. These are the comparisons of Kelvin-Planck statement and Clausius statement. What's the meaning of heat pump? Heat pump is a device. It's a transfer heat energy from a source of heat to what is called heat sink. Heat pump move thermal energy in the opposite direction of spontaneous heat transfer by absorbing the heat from a cold space and releasing it to a warm one. Heat pump uses a small amount of external power to accomplish the work of transferring the energy from the heat source to heat sink. What's the meaning of heat engine? Heat engine it is a cyclically operating device which absorbs energy as heat from a higher temperature reservoir, convert part of energy into work and reject the rest of the energy as heat to a thermal reservoir at low temperature. The working fluid is a substance which absorbs energy as heat from a source and reject energy as heat to a sink. The reservoir is, the thermal reservoir is a large system from which a quantity of energy can absorb or added as heat without changing its temperature. Then perpetual motion machine PMM2. If the engine exchange heat to only single thermal reservoir, in which heat is supplied is completely converted into an equivalent amount of work and its efficiency become 100%. This kinds of machine is known as PMM2. The PMM2 violates the second law of thermodynamics. Practically, it is impossible to construct. The efficiency of PMM2 is, that is the work done equal to heat transfer. So speed is 100% of PM2. So the work done and heat supply is equivalent is not possible one. The transfer of heat from a lower temperature region to a higher temperature one requires special devices called refrigerator. The refrigerator are cyclic devices and working fluid used in the refrigeration cycles are called refrigerant. The objective of refrigerator is to remove the heat from the cold medium. The objective of heat pump is to supply the heat to warm medium. That is, COP of refrigerant is equal to the ratio of the desired output to required input. COP of heat pump means desirable output to required input. That is a formula for COP of heat pump equal to COP of refrigerant plus 1. Thank you.